Hey there, statistics class. This is lecture 3.3 in your book, all about box and whisker plots. And the big thing, it mentions percentiles too, and the big thing to recall about a box and whisker plot, which I've put a little example here, is that it has 4 sections to it called quartiles. And so when we talk about percentiles, box and whisker plots are really looking at the lowest quarter, the first quarter, the second quarter, the third quarter, and the fourth quarter, the highest 25%. So in this lecture, we're going to talk about how to compute median, quartiles, and the 5 pieces of information. We're going to make box and whisker plots, interpret them, and then describe how we can compare what that means with regard to the median, and then compare some examples. So to make a box and whisker plot, you need 5 pieces of information. You need the min, or the lowest data value. You need the median, or the middle number. You need the maximum, which is the highest value. And when I put Q1, I'm referring to the lower quartile, and Q3, I'm referring to the upper quartile. Now, what is Q1 and what is Q3? Well, Q1 is the median of the lower half of data values, and Q3 is the median of the upper half of data values. Now, you've heard of range before, well, the range being the max minus the min. The interquartile range is the third quartile minus the first quartile. So that's the middle 50% of the data, and what that looks like right here is, this is kind of interesting. So the first 25% of the data is here in the first quartile. The second 25% is here, second quartile. The third quartile is right here, the upper 75%. And then the top here is the upper 25%, this little piece right here. So what we're saying when we look at the interquartile range is you're saying, hey, half of the data, the middle half of the data, is between the third and the first quartile. And I'll show you how this plays out in just a bit. All right, let's go ahead and make a box and whisker plot. So first of all, I put my data in order, and you may recall these numbers from the first lecture. Now what I'm going to do is find the median. So I've said there's 13 numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers. Okay, let's see. Let me go back and use my formula. Do you remember how to find this? You say the median is the numbers you have plus 1 divided by 2. So that's 7. So that means the 7th number, 1, 2, 3, 4, 5, 6, 7, this number right here is the median. Equals that 4. That's the first piece of information I need. Let's find the max and the min. The minimum, well, that's easy. That's 2. The max is 8. All right. So far, so good. Now what I need to do is find the median of the lower half, which is quartile 1, and the median of the upper half, which is quartile 3. When you have an odd number of data points, like this one, I have 13, that middle number, the true median, you basically just ignore it, and then you break it down into 2 halves. So here's my lower half. And here is my upper half. Now, since I already have the purple marker, let's just start with the upper half. Quartile 3 is the median of the upper half. Okay, well, this one's actually pretty easy to do. How many numbers do I have? I've got 1, 2, 3, 4, 5, 6. All right, so I've got 6 divided by 2. It's the third number. So wait a minute, that doesn't make sense. Oh, I have to average the 2 middle numbers. So I take these 2 numbers right here, the 4 and the 5. Right, it's 3 from the left, 1, 2, 3. 3 from the right, 1, 2, 3. I average 4 and 5. 4 plus 5 divided by 2. 9 divided by 2 is 4.5. So Q3, let me write it here. Q3 equals 4.5. I'm going to do the same thing on the lower half. Again, I know it's going to be 3, so 1, 2, 3. 1, 2, 3. Aha. 3 plus 3 divided by 2 equals 3. So Q1, the first quartile, is 3. Now I have my 5 pieces of information. Yay! I love having 5 pieces of information. So now what I need to do, I'm going to move my picture out of the way, is actually make this plot. So here I've got a number line. Let me see, I need to go from 8 to 2. Let's just do it this way. We're going to say 4, 8, 5, 6, 7, 3, 2, 1, and 0. Now, let me start right with my median, which is at 4, and I put a bar right where the median is. Then I take my quartiles, quartile 1 and quartile 3, and I make the box starting at quartile 1 and going all the way up to quartile 3. So 3, I make a bar, and then I go up to 4.5, which is, and you do a very good job with keeping everything nice and uniform. It's really hard to use a ruler on the smartboard. So again, quartile 1 is right here. The median is right here. Quartile 3 is right there. All right. Now, continuing on, I need to put the whiskers. The whiskers go all the way to the minimum and the maximum value. And my minimum is 2. And this maximum is 8. Sweet. I have just made a box and whisker plot, and I can see that my data, let's see, the middle half of my data is right here between 3 and 4.5. My lowest value is 2. The median is slightly shifted to the right in that middle half. I bet this data is skewed to the right because I've got a tail. I've got a long tail, way over here. So if I wanted to calculate the range, let's get that purple marker out. My range is max minus min. So that range would be 8 minus 2, which is 6. If I wanted to do the interquartile range, IQR, that's Q3 minus Q1. That would be 4.5 minus 2, and that's 2.5. And that's the middle 50%. So half of my data values, half of them, fall between 4.5 and 2. All right, so how does this actually look in the real world? Well, a lot of these plots, they actually do vertical box and whisker plots, and that's great. It's an easy way to compare different data values. So this graph here is showing you days of the week, Monday night through Sunday night, and then the number of hours of slept. And this might have been a compilation after a number of values or whatnot. And here you can see that the median for Monday was 7.5. Tuesday is about 7. Wednesday, 6.5. Thursday, maybe closer to 6. It's the number of hours you slept that night. You can then clearly see over the weekend, whoever this person is or class is or whatever, clearly their median shifts way up, right? I mean, you're saying, wow, your median was 9 hours? Your median was 8.5 hours? And you can also see that the interquartile range here is much bigger. It's more spread out. And the total range of the data values is more spread out as well. So this is the interpreting the data. So if I said, hey, which night do people sleep the most consistently? Well, what I would be looking for is the tightest data values, the tightest box, and then the tightest whiskers. And I would look at Wednesday night and say, you know what? On a typical Wednesday night, they've gotten between 7 and 4 hours of sleep, and really the bulk of that is between 6.5 and 5. So they're pretty consistent on Wednesday night. But when you look at the weekend, I mean, here you're going from nearly 12 all the way down to 5. I mean, it's like a 7-hour range. In fact, the middle 50%, we're going from 10.5 to about 7.5. They have a 3-hour interquartile range. Boy, I don't know, are they partying on the weekends? Are they not getting enough sleep? Do they have commitments? What are they trying to do on Sunday? I don't know. Remember here, one final thought before we go, is that the reason box and whisker plots are so helpful is some data values are prone to extreme values, very high values, very low values, and that's why we don't use averages, we don't use mean, but we use medians. So when we want to get more information out of data that can be skewed, that's where we want to think about medians, and that's where box and whisker plots are so helpful.